So what we did was halogenoalkanes, we talked about their formation, free radical substitution, electrophilic addition of alkenes. You will get a halogenoalkane. Then we did कि alcohol से भी halogenoalkane बनता है. You what you need to do is you can add phosphorus chloride, and you can add SOCl2, and you can add HCl. या फिर ये सारी reactions थे, bromoalkane, iodoalkane, and 4-chloroalkane. ठीक है, these were all the reactions that would result in the formation of halogenoalkanes. I told you about primary, secondary, and tertiary halogenoalkanes. We did an example. Primary halogenoalkane is where you have a Cl, and that is only bonded to just one carbon chain. आपके पास इसी तरह you have a secondary halogenoalkane. The carbon is bonded to 2 carbon chains, and you've got a tertiary halogenoalkane. The carbon is bonded to 3 carbon chains. फिर ये था कि there's a nucleophilic substitution reaction where the Cl gets substituted by OHCN or with NH2. Okay, there were 3 different reactions, and your OH would get substituted by any three of these nucleophiles. Okay, it was known as nucleophilic substitution reaction, known as SN reactions. Okay, so इसका mechanism, ठीक है, what's the mechanism? So as a reaction is simple. You've got a Cl, it gets substituted by OH ions. So OH ion is the nucleophile. Cn-1 is the nucleophile. A nucleophile is something that is attracted to क्या होता है nucleophile? It's something that gets attracted to positive charge. Okay, that's and can donate a pair of electrons. And it has extra electrons, and it can give those electrons to somebody else. Okay, so that's what a nucleophile is. उसको लिख लेते हैं यहाँ पे कि we already did this. Nucleophile is something that is a species that is attracted to positive charge. And what it can do is can donate a pair of electrons. Donates a pair of electrons. अच्छा, so this one is as a nucleophilic substitution reaction, there are 2 types of reactions. One of them is an SN2 reaction mechanism. SN2 reaction mechanism is it's for tertiary, not for tertiary but primary halogenoalkanes. Okay, so it's primarily for primary halogenoalkanes. Now, what happens in this case is you've got a primary halogenoalkane. It's got only one carbon chain that's attached to the alpha carbon, जिसके साथ Cl attached होता है. So there's this carbon, and there is Cl, and there is H, and another H. So this one has just one carbon chain. ठीक है, ये उसके साथ ना, this is the carbon chain that's attached to it. So this is a primary halogenoalkane. The carbon has a very strong positive charge. The Cl has a very strong slight negative charge. Because it's a polar bond, there's a difference in electronegativity. So what happens is, if you add a nucleophile to it, and that nucleophile could be OH-1, or it could be Cn-1, or it could be NH3, any one of them. So what will happen is that the nucleophile is going to get attracted to the carbon that's positive. ठीक है, बल्कि थोड़ा सा curly arrow draw कर ले. अच्छा, so and it's अच्छा, so it's going to get attracted to the carbon that's positive. And when it gets attracted to this carbon that's positive, तो यहाँ पे जो electrons होते हैं ना, which are this bond over here, they are going to be repelled. ठीक है, they're going to be repelled. Why? So they're going to be repelled because there's negative charge coming in from this side. So the OH-1 is very strongly attracted to this carbon that's positive. So ऐसा करके ना, the electrons over here are going to get repelled because there's negative charge coming in. And also let me, ये खैर वो बाकी दो nucleophiles भी हो सकते हैं, ठीक है. In the next step, ये clear है ना? Unaid, is this clear? Rafik clear है? Ahmed clear है?
जी सर.
अच्छा, next step है कि this
Yes, sir.
this molecule over here, अच्छा, then you'll be asked to draw this, ठीक है. So the next step is you have this molecule. Now for a very momentary instance, ये जो Cl है ना, it will start getting pushed away. And the OH will start to join with the carbon atom. So it's kind of a partial bond formation. The Cl is getting knocked out, and it will eventually get pushed away because OH अपने electrons लेके आ जाएगा, ठीक है? So it's going to join up, and this entire thing will have a -1 charge because OH -1 has joined in. Okay, next step, obviously the next step, the Cl will eventually get knocked out. So your molecule will become this thing. So next step is okay, finally the OH OH joins in and the Cl -1 has been pushed away. You get a simple mechanism, but you have to get every single arrow to be drawn exactly the way they should be, okay? So here's your overall. Here's your overall reaction. And the same thing would happen with Cn-1, the same thing would happen with NH3 as well. In all cases, it's going to be pretty much the same. The same exact diagram. This one over here is known as a transition state. Okay, that's known as a transition state. A transition state is a very unstable state that is formed where carbon for a very is making partial bonds with 5 atoms or groups. But only partially. So that's one thing, and the other thing is this is a one-step reaction. A transition state is just it's not actually a very stable state. It's a very unstable state that only exists for a very small temporary instance. Okay? So remember, this is a one-step reaction. So Sn2 reactions it's a one-step mechanism. So this entire thing is a one-step mechanism. Clear है बात सारी?
Yes, sir.
अच्छा, अब अगला जो है ना, that's an SN1 reaction mechanism. अच्छा, that's an SN1 reaction mechanism. What happens in this is it's firstly it's for this happens for tertiary halogenoalkanes. So now the difference that happens in this case is, so the difference that happens in this case is in tertiary halogenoalkanes is that the carbon is surrounded by large groups. So it's got a Cl on one side. और फिर बाकी साइडों पे ना it's got CH3 and another CH3 and another carbon chain. Let's say a bigger carbon chain. Let's say it's got CH2, CH3 attached to it. As it's got CH2, CH3 attached to it. Now the carbon, again, in this case as well, is has a positive charge. And the Cl has a negative charge. But the nucleophile does not strike first. Reason being that the carbon which is positively charged is surrounded by large groups. So it's on all sides, it's surrounded by carbon chains. So it can't really come close to this carbon atom. So initially, the OH ions, they don't do anything. So what happens initially is कि OH ion उस carbon के करीब भी नहीं आ सकता because it's on all sides, it's surrounded. So initially what happens is that the bond breaks heterolytically on its own during a collision. Okay, there is no OH minus 1 that's pushing from the other side because the OH minus 1 cannot even come close to this particular carbon atom. Okay, it's very hard for it to even reach it. So खुद ही टूटता है. So it's going to take a lot of time. So this is going to be the first step. Is going to be a very, very slow step. So this one will be a slow step, and but eventually it's going to break. So eventually it's going to break, and the Cl will become negative. It's going to take both electrons, and the carbon will become positive. Okay, the Cl negative will go away. Now, when this happens, now you've got an opening, and the nucleophile will slip in. Okay, so the Cl minus 1 will break and leave. Or अब ये होगा कि OH minus 1 or any of the other nucleophiles with their electrons, they can now come in and they can join with this carbon atom. Okay? So it could be the other ones as well. It could be Cl minus 1, it could be NH3. So it could be any one of these. तो अगला step होता है कि the molecule is formed. I mean, the OH comes in and eventually bonds with it. And your displacement reaction is now complete. The second step, the first step was slow. The second step is it's a relatively fast step because you don't have much going on. In the second step, the Cl-1 has already been knocked out, or it's been knocked out, and very quickly the OH-1 they step in and they grab the carbocation. Okay, so इसके अंदर you have an intermediate carbocation that is formed. So an intermediate carbocation is formed, and you've got a slow step and you've got a fast step. So is this clear? ये दोनों clear है mechanism?
जी सर.
ठीक है, कोई ज्यादा फर्क नहीं है दोनों में. It's just that in the first one, primary, the carbon is kind of exposed. It doesn't have large groups surrounding it. There's just hydrogen atoms. So the OH-1 comes directly, bonds to the carbon atom, and the Cl immediately gets knocked out. The OH Cl is going, that's it. Second step, the Cl gets knocked out first because the OH cannot reach the carbon that's right in the middle of the molecule. And when the Cl leaves, then the OH comes in, okay? And then you get this nucleophilic substitution reaction. But anyways, अब इसकी explanation ठीक है. You have to explain why is the first one Sn2 and why the second one is Sn3. तो उसकी जो explanation है ना, which is कि paper में क्या लिखोगे? So the question is, why do primary halogenoalkane undergo Sn2 mechanism? Okay, that's the question. So the answer to that is they have a very unstable carbocation. This is what happens. If you have, और इसके साथ ही दूसरा भी लिख लेते हैं, why do primary undergo Sn2 and tertiary undergo ठीक है, why do they undergo Sn1? अच्छा, so the answer to that is the carbocation formation. If you have a primary halogenoalkane and it's got a Cl, it would be very hard to form the carbocation in a primary halogenoalkane. In tertiary, it's going to be easier. If I have a tertiary halogenoalkane, it's going to be a lot easier to actually form the कि अगर हर side पे carbon chain है ना, and I've got a Cl on one side. So it's a lot easier to actually form the carbocation in this second case. और वो इसलिए इसको नीचे अच्छा, so why is it easier to form the carbocation in the second case? So let's say the Cl has gotten knocked out. So the Cl is -1 and it's got the lone pairs and you've got a carbocation. In the other one, exactly the same situation. The Cl has been knocked out It's -1, and the carbon has a positive charge now. ठीक है, तो दोनों केसेस में ना this is what has happened. In both cases. Achha, so the question is, why can't the first one form a carbocation? तो उसमें ये answer ये कि we did this previously as well when we did Markovnikov's rule, and I told you that when you're surrounded by large alkyl chains, there are 9 electrons over here, there are 9 electrons on this side, there are 9 electrons on this side. So what happens is that you are surrounded by electrons, and this positive charge is going to be very, very small. Why is it going to be very small? Uski reason है कि there are too many electrons that are around it. So if you've got a positive charge right in the middle of the molecule and you're surrounded by electrons, the positive charge is going to quite an extent get neutralized, right? तो ये idea clear है कि यहाँ पे positive charge बहुत small है. Is that clear?
जी सर.
Yes.
तो इसका मतलब है फिर Cl-1 को attract क्यों करेगा? It's not going to attract Cl-1. So it would be easier for the Cl-1 to actually leave. Is that clear?
जी सर.
Yes.
But on the other hand, you don't have a lot of electrons because it's not surrounded by large groups. There's only one electron in this, one electron over here. So the positive charge over here is going to be large. Okay. So because of that, the Cl-1, instead of leaving, will actually be very strongly attracted to this carbon atom, right? So it would be a lot harder for the Cl to actually leave on its own. तो क्लियर है दोनों बातें कि यहाँ पे Cl जो है ना, that will be, it won't leave on its own. यहाँ पे Cl can leave on its own. Is that clear?
जी सर.
Yes.
तो प्राइमरी के अंदर ना you have to have someone pushing the Cl out. मतलब OH-1 आता था and then it will push the Cl out, right? Over here you don't need anyone to actually push the Cl. The Cl would just leave on its own because the carbocation that is formed is very, very stable. It's got a very low charge density. तो उसकी एक्सप्लेनेशन बस आपने ये लिखनी है कि so the answer is tertiary carbocations. ठीक है, that's your answer. Tertiary carbocations. They have more electron rating. Alkyl chains, which decreases charge density on the carbocation. So on carbocation, making it very stable. So hence Sn1 mechanism. Okay, that's why you're getting an Sn1 mechanism for tertiary carbocations. Or vice versa, you can write for primary carbocations that they have fewer. मतलब सब कुछ सेम ही होगा, बस यहाँ पे चेंजेस कर लेते हैं. ठीक है, so the only difference is going to be कि first वाला part इसको primary carbocations कर लेते हैं. You call them 1 degree carbocations. So this is, have less electron donating alkyl chains, which therefore increases charge density on the carbocation, making it very unstable. Hence, you have an Sn2. You don't actually form the carbocation. It would be very hard to actually form the carbocation. ये वाला primary था. And this one is tertiary. So is this clear why the mechanisms in one of the cases someone has to come in and push the Cl out, and the other one the Cl gets knocked out on its own, okay? And then the OH comes in. Okay, is this clear?
Yes.
Yes, sir.
Plus you also have to understand that I say 1 or 2 kiya hai. Why am I calling that Sn2? Why am I calling this Sn1? This one indicates that the speed of the reaction, ये जो tertiary halogenoalkane का mechanism है ना, why is it called Sn1? So that Sn1 indicates that the speed of the reaction depends on only one of the reactants. So rate only depends on the halogenoalkane concentration and not on the nucleophile concentration. Okay, so it does not actually depend. Rate depends on only one reactant. I say it only depends on one reactant. So that's why it's called Sn1. So why does it depend on only one reactant? It's because reactants hai kaun se? You've got this halogenoalkane and you've got OH minus 1. These are your two reactants. Halogenoalkane, Cl breaks off, the OH comes in. These are your two reactants. You've got two steps. One is a slow step, the other one is a fast step. I should remember this is a proper two-step reaction, okay? So this one is a two-step reaction. It's got the first step and then the second happens. Or जब ये word intermediate लिखा होता है, that means that thing actually forms in the reaction, and then you get this other thing. But anyways, why do you call it Sn1? Why is it not? OH concentration, if you increase it, there'll be more collisions. Which of the two steps will increase in speed, the slow step or the fast step?
Fast.
Take a fast step. Remember, fast step increase करने से ना, the rate of the reaction barely changes. Why? Because let me give you some values. Okay, let's say this is 100 seconds. And this one over here is taking 1 second. So what is the overall time for the reaction? That's 101 seconds, right? 100 seconds for the first one, 1 second for the second one. Okay, if I increase the speed of the fast step by increasing the concentration of the nucleophile, jitna marzi increase kar lo, the overall speed of the reaction will barely change. Okay, wo 101 seconds se kitna tez ho jayega? It's just going to become 100 seconds, right? So the idea clear that increasing the speed of the fast step does not have any effect on the overall speed of the reaction. Is this clear?
Yes, sir.
Yes,
I said, what if I increase the concentration of the halogenoalkane, this one? So which of the steps will increase in speed? It's going to be the slow step, right?
Yes.
So if 100 seconds or 50 seconds ho jata hai, to obviously there's going to be a drastic change in the overall speed of the reaction. So is this idea clear that the rate of the reaction is not dependent on the OH concentration? It only depends on the concentration of the halogenoalkane, which is why you call it Sn1, that it only depends on only one reactant. ठीक है?
Yes, sir.
okay, sir.
Or पिछले में the rate of reaction, actually you call it Sn2 because because there was only a single step, right? तो एक ही स्टेप है, तो this is just a transition state. This is like the reaction happening in slow motion. So slow motion में ना बीच में this is what's happening. The Cl getting knocked out. So if there's only one reaction, the rate depends on that step, right? So either increase the OH concentration or increase the halogenoalkane concentration. In both cases, the rate of the reaction will speed up. So this case में होगा कि rate depends on both reactions. That's why you call it Sn2. ठीक है, तो यहाँ पे लिख देते हैं कि अच्छा, rate depends on both reactants. Is that clear?
जी
तो मतलब उसको ना इक्वेशन फॉर्म में भी लिख सकते हैं कि रेट डिपेंड्स ऑन द halogenoalkane concentration. It also depends on the OH ion or the nucleophile concentration as well. ठीक है, दोनों के ऊपर डिपेंड कर रहा है। तो बस ठीक है, that's nucleophilic substitution. So you have 3 nucleophilic substitution reactions. All of the 3 are very important. Okay, it's NaOH, NaCN and NH3, और ये उसका Sn2 और Sn1 मैकेनिज्म है। तो इधर अगर वैसे मुझे बताओ कि हाँ, सेकेंडरी का डिस्कस ही किया। व्हाट विल हैपन टू द सेकेंडरी हैलोजेनोअल्केन? वो दोनों का मिक्सचर होगा।
Did it go through both, sir?
I mean, it depends. ठीक है, secondary it depends because it all depends on the stability of the carbocation, right? Whether it's easy to form the carbocation or whether it's difficult to form the carbocation. But the first case it's obviously difficult. I mean, it would be the carbon has a very strong positive charge, ठीक है? मतलब यहाँ पे the Cl will not leave on its own. So someone has to come in and push the Cl out. Second, इसमें the Cl leaves on its own because the carbon doesn't have a very strong positive charge. So secondary जो है ना वो mixed है. So it can undergo kind of a mixture of both. यहीं पे add कर देते हैं. So it depends on the conditions as well. So let's say both Sn1. So it depends on the condition. ठीक है, depends on conditions. चलिए ठीक है, ये फिर ना आगे कल करते हैं। ठीक है,
ओके
ओके, टेक केयर, अल्लाह हाफिज।
अल्लाह हाफिज।
Okay. Thank you, sir.